Good morning to all of you. Today we will see the possible problems for individual order kinetics. First we will see the zero order and what are the possible problems that can be asked in the zero order, for which you should know what are the possible kinetic equations available. First of all, you should know the relationship between them or use the standard the kinetic equation by n minus 1 by 1 power a t power n minus 1 minus 1 by a naught power n minus 1. This equation you should know this, from which are the possible relationships equations possible for the zero order. First, the kinetic equation K0 2 is equal to A0 minus AT. This is the equation already we have derived. What are the possible problems that we be asked from the kinetic equation? A is not P variable, time is variable. A0, initial concentration we have taken is said, and A0, the amount of concentration left. Therefore, the three variables are there, K0, T, and AT. Therefore, if a direct problem is asked, three possible questions cannot may be asked. You should be given what is AT or what is the amount of the reactant consumed. The amount of the reaction consumed, if you know, you can calculate the AT from A0 minus X. X is the amount consumed. That can be calculated. Therefore, if cannot is asked, T should be given, A0 should be given, and what is the amount that is reacted should be given, or what is the amount left should be given. In this type of problem, students should be very cautious. Sometimes the reaction or the concentration of the reactant is decreased by 20%. The concentration of the reactant is decreased to 20%. Whether these two are having the same meaning, they are having different meaning. Now let us assume initial concentration is 100. After the time t, the concentration is decreased by 20%. Means the concentration decreased means that is the amount reacted is 20%. Therefore, AT is equal to 80%. If this is given, the concentration is decreased to 20%. What do you mean by it? Initially it is 100. After the time t, it is changed to 20. Therefore, this is equal to 80. Therefore, when you are given as the concentration is decreased by 20, the by 20 indicates the amount reacted, decreased to 20, it equals to the 80. Therefore, you should be very cautious about the wording in that one. Therefore, if you are asked to calculate this, you can apply this equation and problems can be, we can work out any one of the models for this. K0 may be asked, T should be given, A0 should be given, and AT should be given. It's a direct substitution. There is another type of, from using the same equation, another type of is, two times we have two set of data should be given. We have already seen. That is, in time t, the concentration is decreased or concentration is changed with 85%. In time t, 80% of the reactant has been converted. What would be the time required for 10% of the conversion? For 10% of the conversion. It is not between 75 and 50. 75 and 15 are given. We will have a separate equation. We can make use of that equation. But 85% requires, say, 100 minutes. What is the time taken for the zero order reaction for the completion to 10%? For this, you have to make use of this equation two times. But that is a methodology to be used in the class purpose. but in CSIR examination, it will take some more time. We should reduce the time of solving the problem, for which we can give one thing. K naught is equal to A naught by AT by T. What is A naught? AT. AT is the amount left after time T. In terms of amount consumed, A naught is given as A naught, AT is given as A naught minus X. That is amount consumed X. Therefore, you can substitute in this. You will get A naught minus A naught plus X by T, or you can simplify it as X by T. Therefore, K naught is equal to X by T. It is a simplified form, where X is the amount reacted in time T, from which you can easily calculate K naught. You are not necessary to go all of this like this. And you can make use of this equation for two sets of data. When after the sudden 85% is completed in 100 minutes, what is the time taken for 10% completion, for which was 85%, that is amount reacted, X1, and the time taken, T1. You are asked for X2 concentration, what is the time taken. For this reaction also, the K naught is same. Therefore, we can write K naught equal to X by T as X1 by T1 equal to X2 by T2 equal to X3 by T3, and so on. You can write down. You can give any percentage of conversion and the time taken. You may be asked to what is the percentage of conversion in time T2, or what is the time taken for the conversion to X2. Two types of problems may be asked, for which you can make use of the simplified equation. This equation is derived from this equation. This is direct substitution. It is using two sets of data to be calculated. And which formula should be used? You have to decide that one. And the next one is what is the time taken for 50%. You have already known this. What is 50% of the conversion? What is the equation for this zero order reaction? Tell me what 50%. Half-life is equal to what is the general formula? Kn T 50% is equal to 1 by N1 into 1 by A naught N minus 1 into 2 power N minus 1 minus 1. Put zero order T 50% is equal to A naught by 2 K naught. A naught by 2 K naught. This equation you should use for the calculation of the half-life period for the zero order reaction. And what are the problems, types of problems that may be asked in these two types of problems only can be asked, because it involves the A naught is a constant and T 50% is a variable and K naught is a constant. Therefore, of these two, if A naught is given and T of is given, K naught may be asked, or A naught and K naught is given, 50% may be asked. Therefore, only a direct problems can be given in this. This is the equation. Similarly, what is the conversion for T 75%? You can make use of that equation. If T 50% is given, you know the formula 2n minus 1 plus 1 into T 50%. In the last class, I have forgotten to give you one ready-reckoner relationship between this T 75% and T 50%. What is that relationship? And if you use the ready-reckoner, you can do the problems. We have calculated, used the equation for two problems. T 75% is given, T 50% is given. Then you are asked to calculate what is the order of the reaction. For which a ready reckoner is there. What is that ready reckoner? If 75% and 55% time is given, find out the ratio. For example, one is having 30 minutes, T75 is 30 minutes, and T50 is 10 minutes. Ratio is 3. If the ratio is 3, then what is the order of reaction? That can be readily seen. For example, convert this into the 2n minus 1 plus 1. For zero order reaction, what would be the ratio? Find it and tell me the answer. For zero order reaction, the T75 and T50% would be equal to, what would be the ratio? Anybody calculate it and tell me the answer. No, I am not asking the order of the reaction. What is the ratio of 75 to 55% conversion for a zero order reaction? There's always a constant. What is that ratio? I am asking that. Calculate, put n is equal to 0 for zero order reaction. What would be the value? 3 by 2 is 1.5 for zero order reaction. Therefore, sometimes 75% and 55% conversion time would be given. You may be asked to which order this reaction will follow. So input the ratio. If it is 1.5, you may immediately say it is zero order. Similarly, for first order, tell me the value for the first order. 2. This 2 power 1 minus 1, 2 power 0, 1, 1 plus 1, 2 இருந்தால் definitely it is a first order. இங்க ஒன்று கொடுத்துருக்கிறேன்னு இது என்ன ஆர்டர் கிடையாது, ஜீரோ ஆர்டர் இல்லை, ஃபர்ஸ்ட் ஆர்டரும் இல்லை. We will go for next second order. Substitute the value and find out the value of the ratio 75%, 55% conversion. Third order. Third value is 3. Therefore, it is a second order. Therefore, now for this phenomenon, if 70% is divided by the 50% conversion, what is the ratio? Immediately you will tell this is a second order reaction. What would be the ratio for a third order reaction? Tell me the answer. Third order reaction.
5.
5 is the third order. Now, what would be the ratio of these for the 0.5 order? Its value should be lying between. Its value should be lying between. 2. We will take the average. What would be the average? Nearly it should be 1.75. Calculate this. What would be the value? I am taking the average of these two. It is 1.75. But actual value is, it is 1.7, I think so. 1.7. Similarly, what would be the value for a 1.5 order? The value should be lying between. Value should be lying between 2 and 3. It may be nearly 2.5, but the correct answer is 2.4. Similarly, what about for the 2.5 order? 2.5 order, second order value is 3, and for third order it is 5. This is 4. Actual value is 3.85. Therefore, if this ready reckoner you know by heart, then no necessity of doing calculation. Just to find out the ratio of these two life periods, immediately you will come to the conclusion what would be the order of the reaction. Now, we will go back to the Babelian, that is zero order Babelian. T is 75 and this is the relationship, and you can, instead of this, you may be put 1.5 into T 50%. How many types of problem may be asked in this? Only 2 types of problem. 75% conversion time is given. What would be the 50% or vice versa? This may be asked, it's a direct question. Okay? And using these formulae, we can give a number of problems. Shall we start doing problem in this section? Take down the first one, a zero order reaction. A zero order reaction takes 10 minutes for 50% completion. Takes 10 minutes for 50% completion. How long it would take for 75% completion? சொல்லுங்க பார்க்கலாம் என்ன ஆன்சர் வரும். இதுக்கு 10 மினிட்ஸ் தான். இதுக்கு எவ்வளவு இருக்கும் அப்படின்னு கேட்டிருக்காங்க. எவ்வளவு வரும்? 15 மினிட்ஸ். இமீடியட்டா அதை போட்டு மல்டிப்ளை பண்ணீங்கன்னா கிடைச்சிரும். Or you can make use of this equation also. This one, that is x1 by t1 is equal to x2 by t2. It will also give you the same result. 75% of time conversion by t1. That is as x2 is 50% of the conversion. The time taken is 10 minutes. What is t1? t1 is equal to 75 into 10 by 15. And you will be having the answer 15 minutes. Either you can make use of this equation or you can make use of this equation. I have already told you this x1 is the percentage of conversion for a particular conversion and the time taken is given, and you can make use of any percentage. But this conversion can be used only for 75 and 50%. 87% is converted in 200 minutes. What is 50% conversion? You can't use this equation, but you can use this general equation. For 75-55%, that can be applied, that can also be calculated using this equation. Therefore, you can make use of this equation for any percentage conversion. Okay, now, next type of problem, take down the problems. Find the relationship between T half and T7 by T half and T7 by 8, T half and T7 by 8 for a zero order reaction. Now I am going to calculate this in two ways. The simplest way is you can use this. Whatever may be the fraction given, you can adopt this equation. First we will give what is the percentage of conversion for this, what is the percentage of conversion. You can make use of, instead of a percentage, you can give the fraction itself. That is also sufficient. X1 is equal to nothing but half of the A1 or half of the X1 equal to 50%. You can make use of it, or half it is sufficient. The time taken for it is T half. It should be equal to, what is the fraction to be converted? 7 by 8. The fraction to be converted is 7 by 8 divided by T of 7 by 8. Now, what is the relationship between this time taken and this time taken? Given, just cross multiply it, you will get half into T of 7 by 8 is equal to 7 by 8 into T half. That is equal to T of 7 by 8 is equal to, cancel this 7 by 4, T half. This is the relationship. This is the simplest way you can derive. Or you can make use of this equation. You can make use of this equation, substitute that the initial is 1 and the amount left is half, and you have to find out the T half first, and then you have to substitute once again 7 by 8 here and substitute and find out the T7 by 8 and then compare this. It will take a longer time. Therefore, in the CSI or like a competitive examination, you can make use of this equation. Not only T half and T7 by 8. What would be the correlation between T 10% and T 80%? What is the relationship between them? You make use of this equation, it will be very, very easier for you. Next type of problem we are going to see is consider the reaction. Consider the reaction. 2A plus B giving 3C plus D. 2A plus B. This type of problem I think so far not asked, and it is excess. The rate of the reaction or a zero order kinetics is 10 power minus 3 mole per liter per second. If initially 10 moles of A were kept in 2-liter container, find the time in which the concentration of D becomes 2.5 molar. Concentration of D becomes 2.5 molar. This is the equation that is given. And here I look at the stoichiometry of the equation. 2A plus B giving 3C plus D. Here B is taken in excess. Whenever one of the reactant is taken in large excess, the concentration change is negligible. We can consider it as a constant. Therefore, with respect to B, it is Oswald's isolation method. It is a constant. We will take it outside soon. Therefore, now the order of the reaction is a zero order with respect to A. But so far we have considered what is the rate of the reaction as zero order. We will give only one concentration term is given. Only one concentration term is given. And the rate equation for this we have written as K naught into T is equal to A naught by AT. But if here that is for this type of reaction, that is the constant stoichiometry of the reactant is only one. We have derived the general equation assuming that the stoichiometry of the reaction is 1. But whenever the stoichiometry is given like 2 or 3 or 4, etc., that rate equation is slightly changed. You have to, whenever you derive this, what is a slight change, how it is changed, I'm not going to discuss this. And from the rate equation, you derive this, you will finally get this equation. Only thing is, if 2 is present, multiply it by the equation 2. If 3 stoichiometry is present, 3, or it is half is given, half K0T. You have to make use of this equation for this one. Otherwise, if it is given like this and it is a zero order, you can make use of K naught T equal to A naught minus AT. I think you understand the etc. And next then, this K naught is given, I think, so it's not. The rate of the reaction is given. The rate is given. And what is the one? How to find out? But you are going to calculate only the K naught. What is the rate of the reaction? We have already seen rate of the reaction is equal to minus half d of A by dt. is equal to 1 by 3 into d of c by dt equal to d of d, change in the concentration of d with respect to t. Here you should not, that rate is not depending upon the p given reactant because it is taken in large excess. Therefore, this one, therefore, what rate is given and what is the rate is nothing but equal to K for zero order reaction. Therefore, from this rate, you have to calculate K naught. Therefore, K naught is equal to how much? The rate of the reaction is given. It is 10 power minus 3. Therefore, K naught is also 10 power minus 3. You should, only rate is given. How can I use this here? K naught. What is the rate of the reaction? That is equal to K. Therefore, K is equal to not 10 power minus 3. Keep it in mind for a zero order reaction. The rate, if rate is given, that is nothing but K naught. And you may be asked to calculate what is the rate of disappearance of this, what is the rate of the appearance of C, what is the rate of appearance of D, etc. Sorry, okay. Now, what is the equation to be used? Here we have to make use of this 2K naught T equal to A naught minus AT. What is asked? What is asked? The time taken, that is T is asked. K naught is already given. And A naught, the initial concentration of the reactant A. What is the initial concentration of A? 10 moles of A is present, are present in 2 liters. Therefore, what is the initial concentration? Concentration is given by moles per liter. Therefore, A naught is equal to 5 moles per liter. 5 moles per liter. Now, what is AT? AT is the amount of A consumed after time T. But here the problem given is, what is given? What is the time in which the concentration of D becomes 2.5 molar? Here the D concentration should be 2.5 molar. At that time, what is the time? இதுவரைக்கும் நம்ம இங்க பார்த்திருக்கிற AT is the concentration left of the reactant A அப்படின்னு பார்த்திருக்கோம். இங்க ப்ராப்ளம் எதை கொடுக்குறாங்க? What would be the time when the concentration of D is 2.5 molar? But 2.5 molar concentration of D is provided. How many molar of A should be undergoing decomposition or undergoing reaction? That can be calculated from the stoichiometry, or you can make use of a methodology procedure. But for CSIR examination, we are going to apply the shortcut method. When 2 moles reacted, the D amount formed is 1 mole according to the stoichiometry. 2 moles of A reacted, the amount of D formed is 1 mole. For 1 mole formation, 2 mole of A is required. For 2.5 mole of formation, how many moles of A would be required? How many moles? Tell me the answer.
All 5 moles.
5 moles.
5 moles.
Therefore, 5 இருக்கிறது எத்தனை moles தான்? இருக்கிறது எத்தனை moles தான்? 5 moles. Therefore, what is the amount left after the time T? It is 0. Therefore, 2 into K naught into T is equal to A naught. What is the value of A? 5. Amount left is 0. Now you have to calculate T. Therefore, 5 divided by 2 into K naught is equal to 10 power minus 3 equal to 2.5 into 10 power 3 seconds. This time is equivalent to 100% completion, is not? And all of them are completely converted, therefore it is equivalent to 100% completion. The problem D should not be asked. Here also C can be asked. What is the time taken for 6 mole of C is formed? If it is asked for the 6 mole of C to be formed, how much mole of A to be consumed? For which you should take the stoichiometry. 3 moles of C would be formed by the consumption of A mole of 2 mole of A. For 6 mole of A to be formed, 16 to 2 by 3, 2. Therefore, how many moles of A would be consumed? 4 moles. Therefore, amount left would be 1 mole. 5 minus 1 divided by this one. That is the time taken for the formation of 6 mole of B. If anybody asks how many more, 8 mole of C is formed, whether it is a right data or wrong data, you can't give any number of moles. For 8 moles, calculate for 8 moles. For 3 moles of 2 moles, for 8 moles, you have to find out 8 into 2, 6 divided by this. 5.33 moles are required. But the given concentration is only 5 mole. Therefore, a wrong data is given. 8 mole cannot be easily formed. The maximum is the only limit. Here, the 2.5 is the maximum for the given concentration of A. And this is considered to be one difficulty level problem. And you can expect this problem this year. Next type of problem we are going to see is take down the problem. 2A plus 3B giving product. 2A plus 3B giving the product. Given 2A plus 3B giving the product. Given concentration of A, initially A, concentration of B, initially 6, rate of the reaction is equal to K into Ca, 0, concentration of B power 0. Find our difficulty level, we will see 3 types of problem, of which only one would be asked. First problem, find the value of C of A at time t, C of B at time t, in terms of A, B, K, and time t. First we will work out this, then we will continue our problem. 3 types of problems are given. First we will find it. What is given? What is asked? This is asked. And what is given? Initial concentration is A, and the initial concentration is B, and the rate equation is this one. Therefore, with respect to A, it is a 0 order. With respect to B, it is a 0 order. Therefore, you have to make a 0 order equation. What is a general 0 order reaction? A naught T is equal to A naught. Here, instead of A naught, you put it as C naught minus Ct, because concentration is expressed in C and And this is for if only one stoichiometry 1 is present. For A, now we are going to apply this for A. The equation is changed as 2 K naught T into concentration of A at the initial, concentration of A at T. You are asked to give the equation for C of A naught T. Now, can you give what would be the equation? This, bring this in this time and bring that one. You will get concentration of A at the time is equal to concentration of A naught minus 2 K naught T. When only one stoichiometry is present, the equation is Ct is equal to C naught minus K naught T. Only one concentration. One stoichiometry is only one is there, but stoichiometry is 2 is present. Therefore, it is 2 K naught T. Or it is also a zero order reaction. You can tell me immediately what is the concentration of B left after time T. It is equal to concentration of B naught minus what is the equation? 3 K naught T. And the next type problem we are going to see this in this one. Find the expression for T of half for the A and T of half for the B. T of half A for the A and T of half for the B. For a zero order reaction, what is the T of this given for a zero order reaction? For a zero order reaction, T half is given by A naught by 2 K naught. A naught by 2 K naught. For if the stoichiometry is 1, if the stoichiometry is 2, the value would be slightly changed. T half of A is equal to A naught. A naught A divided by 2 K naught, but for 2 K naught, K naught should be replaced by the stoichiometry 2 K naught, therefore equal to A by 4 K naught. What will be the T half for the reactant B? Immediately you can tell B divided by 2 K naught. Here K naught is nothing but the 3 K naught. Therefore, it is equal to B by 6 K naught. This is the second type of problem. Anything may be asked. And third type of problem that is asked. Find the condition. Third one, find the condition at which. One problem. Find the condition at which T half of A is equal to T half of B. 50% of A conversion time, 50% of B conversion time, எப்பொழுது ஈக்குவலாக இருக்கும் என்று solve. This type of problems so far not asked, but it is asked. You have to derive T half of A for this A and T half of for the agent B, and this should be equal and this should be equal and mean these two should also be equivalent. That A by 4 K naught should be equal to B by 6 K naught. Therefore, if you take this A by B is equal to K naught and K naught cancel, A by B is equal to 4 by 6, or it should be equal to 2 by 3. That what do you mean by this? The concentration of initial concentration of A should be 2 times and the initial concentration of B should be 3 times. For example, if you take 2 moles of A mean and the B concentration should be 3 moles. That is according to the stoichiometry. Or the concentration of A is taken to be 1, then B concentration should be 1.5. Then only this T half of A and T half of B would be equal. Otherwise, at no time it would be equivalent. This is the condition. And this type of problem is worked out for different kind of reactions. It is zero order and it is first order. What is the T half of A equation? What is the T half of B equation? What is the relationship between when, at what time the T half of A would be equivalent to T half of B? Or it is the first order, when will the T half of A would be equal to T half of B? Whatever may be the questions you will be asked. In such cases, they find that if the initial concentration of the 2 reactants, take down this, the inference from the problem, we obtained is, if initial concentration of the two reactants participating in a reaction is the ratio of their stoichiometric coefficient, initial concentration of the two reactants participating in a reaction is equal to the ratio of the stoichiometric coefficient, then the half-life time of both the reactants would be same. Both the reactants would be same. For hereafter, you need not to work out for this. What would be the time taken for this one? அப்படின்னு சொல்லிட்டாங்கன்னா உடனே immediately you will tell for first order, their concentration should be in this ratio. Now let us assume A plus 3B giving product. This is a zero order and this is a zero order. When will the half-life of A would be equal to the half-life of B? If the initial concentration of A is taken as the 1 mole, the B in the ratio 3, then only it would be equivalent. Otherwise, it is not equivalent. Okay? Then shall we go to the next type of problem in this one? Down the problem. Cl2O7 gas undergoes decomposition according to the reaction. According to the reaction. Two Cl2O7 gas giving 4ClO2 gas plus 3O2 gas. If the rate of consumption of Cl2O7 is equal to 50 tar per second, calculate half-life time. Half-life time. And rendavathu question. The total pressure after 10 seconds if initial pressure is 600 tar. 600 tar. This is the question asked. Half-lifetime. And for half-lifetime, you are in need of PR 50% is equal to A0 by 2A0. If you know the initial concentration, that is initial pressure, and 2K0, K0, the rate constant for a zero order reaction, you can calculate easily. And find out whether the stoichiometry is singular or one or multiple. Here it is 2. Therefore, instead of K0, you have to put 2K0. Now the equation is changed to 4K0. This is the equation you have to make use of it. If it is given 3Cl2O7 0 order means instead of K0, you have to put 3K0 and so on. Therefore, for this problem, this is the equation. Now, A0 is given, it is 600 tar. That is only due to the initial time. At zero time, only Cl2O7 would be present. The amount present is here. Therefore, initial pressure is due to this. Therefore, we take the 600 tar equivalent to the concentration. Therefore, A0 is here. Arrived at A0. Now, we are in need of the K0. Instead of K0, what is it given? 50 tar per second is given. 50 tars, the rate of consumption is given. But the rate is equal to, for this equation, we can write rate is equal to minus 1 by 2 into T of Cl2O7 by dt. What is this value? This equal to theta. Therefore, what is the rate? Equal to 25 r per second. And one thing, what about the order of the reaction? We have forgotten. Is there any order is given? Any order is given?
No, sir.
How to calculate the T 50% using this equation? How to find out the order of the reaction? Anybody? If, from the rate equation, the path the rate is equal to this one and K is equal to so much tar. Tar per second, what does it mean? Concentration per second, as the end of the 1 minus n is equal to 1. Therefore, what is the value of n? It is 0. It is a 0 order reaction. From the units is from the K unit. Now, you put the rate of consumption, you have to find out the K1. From that, you can easily find out this one. Okay. Next time is the half-life period. Now, you can easily obtain the half-life period. What is the K value you have added at 25 bar? Therefore, T 50% is equal to A0 is 600 by 25 into 4. This one, K0 is equal to 25. Therefore, what is the T half? 6 seconds. T half is 6 seconds. Okay. And the next answer for the next question. What is the next question? Answer is that what is the total pressure after 10 seconds? Therefore, after 10 seconds, how much of in the 0 time, this is present 100%. It is 0, 0 or A. But after the time T, what is the amount is present? Let us assume that X mole of Cl2O7 is decomposed. Therefore, A minus X would be left after the time T. What is the amount present, ClO2 present? If 2 moles are present, 2 moles of Cl2O2 decomposes, 4 moles of ClO2 is formed. Here, X mole of Cl2O7 is decomposed. Therefore, here it is equal to 4 into X divided by 2. Here it is 3 into X divided by 2. This is the moles present after the time T. And pressure may be due to Cl2O7. Pressure may be due to the ClO2 and ClO2, and pressure may be due to the opposite. You have to find out what is the value of X, then only what is the pressure due to Cl2O7 at time T, what is the pressure due to the ClO2 at time T, what is the pressure at the time oxidation at time T. Sum of these, you will get the total pressure after time T, for which we are going to calculate the X only. And how to calculate the X only? You can make use of our equation, this one. How to calculate this? We have already given that one. But here it is for 1 molar is present. For our purpose, 2 moles are present. Therefore, 2 cannot is equal to X by T. Why you have put the 2 cannot, you know? 2 cannot is equal to X by T. What is the time given? Time given is 10 seconds. Therefore, 2 into, what is the value of cannot? What is the value of cannot? 25 hours. In the time 10, equal to X. And multiply it, you will get X well is equal to 500 tar. Initially, how much tar is present? 600. After separating the consumed one, the amount in lane or the pressure after T due to the reactant is 100 tars. What is the pressure due to ClO2 after the time T? You put X is equal to 500 here, you will get 1000 tar. And for this, put this one, you will get 750 tar. Sum this, you will get 1850 tar after the time T. Similarly, you may be given calculate at 15 seconds or 20 seconds, whatever may be the. ஆனால் அடுத்த மேக்சிமம் இதுக்கு மேல அது போயிடக்கூடாது அப்படின்னு பார்த்தீங்கன்னா எந்த டைம் எதுக்கு மேல போயிடக்கூடாது சொல்லுங்க பார்க்கலாம். எனிபடி நீங்க கண்ட டைம்லாம் போடக்கூடாது. நீங்க 100 செகண்ட் கழிச்சு என்னன்னு கேட்டீங்கன்னால ஆன்சர் தப்பா போயிடும். மேக்சிமம் எக்ஸ் வேல்யூ எது வரைக்கும் தான் போக முடியும், அமௌண்ட் கன்சியூம் எது வரைக்கும் தான் போக முடியும். இனிஷியல் எவ்வளவுதான் கொடுத்துருக்காங்க? 600. அப்ப எக்ஸ் வேல்யூ should be lying within 600 தான் இருக்கணும். அதுக்கேற்றபடி the time should be variable. அதுக்கு டைம் வந்து 20 செகண்ட் அப்படின்னு கொடுத்தீங்கன்னா என்ன நடக்கும்? 50 × 20 1000 அப்படின்னு வரும். அங்க இருக்கிறதே 600, ஆனா கன்சியூம்டு வந்து 1000. It is a ridiculous one. அதனால whatever may be the time you may be given அப்படின்னு நினைச்சிடாதீங்க. It's a wrong answer. Okay?
Sure.
Shall we go to the next type of problem? Take down the next type of problem. The half-life of a zeroth order reaction. Zeroth order reaction is 250 seconds. 250 seconds. Calculate the half-life. Its half-life when the initial concentration of the reactant increases 2 times. Initial concentration of the reactant increases 2 times. Option, we have already seen 250 seconds, B 500 seconds, C 125 seconds, and D 400 seconds. என்ன பார்த்தோம் last yesterday class? என்ன பார்த்தோம்? The T half is proportional to A initial concentration for 0 order. For 0, it is independent of A. It is equal to 1 for independent for first order, and the T half is proportional to 1 by A for a second order, proportional to 1 by A square for third order. அப்படின்னு சொன்னோம். இங்க என்ன கொடுத்திருக்கிறாங்க ப்ராப்ளம்? It is dependent on the initial concentration. Only one chemical kinetics or first order kinetics T half is independent of initial concentration, or all other the T half involves the rate of initial concentration. Whereas 0 order is directly proportional. What do you mean by directly proportional? The concentration is 2 times increase, the T half is 2 times increase. 3 times increase, 3 times increase, or 2.5 accordingly proportionately increase. And for the second order, it is 1 by A, therefore it proportionately decreases. For third order, it is 1 by A square rate decreases. அப்படின்னு சொன்னேன். இப்போ 0 order, அப்போ என்ன இருக்கணும்? Proportionality increase or decrease, proportionality increase இருக்கணும். என்ன கொடுத்திருக்கிறாங்க? Half-life of a 0th order reaction is 250 seconds. Calculate its half-life when the initial concentration of the reactant increases 2 times. Initial concentration 2 times கூடிட்டாங்களா? இதை 2 times கூட்டிட்டாங்களா? அப்ப T half என்ன ஆகும்னு சொல்லியிருக்கோம்? Proportionately increases. That is 2 times increases. Therefore, 250 into 2.
Option B.
Option B. இதுக்கெல்லாம் ஒர்க் அவுட் பண்ண வேண்டியது இல்லை. அதை பார்த்துக்கிட்டு அதுதான் தூக்கி போடுறேன்னு சொல்லலாம். இதே ப்ராப்ளத்தை எப்படி கொடுக்குறேன்னு வச்சுக்கோங்க. Initial for a given concentration is 250 seconds. Its concentration is 5 times decreased. 5 times decreased. Initial concentration is 5 times decreased. What would be the half-life period? The initial concentration is 5 times decreased. அப்படின்னு போட்டு எல்லா வேலையும் எழுதிக்கோங்க. ஒரே ஒரு வேலையை மட்டும் மாத்திக்கிடுவோம். What is the correct answer? Proportionately it decreases. என்னது படம்? 50. இதாங்க நீங்க ஒர்க் பண்ணி பார்த்தீங்கன்னா அதான் வரும். இதை அண்டர்ஸ்டாண்ட் பண்ணிட்டீங்கன்னா உடனே போட்டுக்கிடலாம். Okay, we will go for another type of problem. If in a zero order reaction, I didn't go there. Calculate time taken. Calculate time taken for the following change. Calculate the time taken for the following change. Option A, 4 seconds, B, 6 seconds, C, 8 seconds, D, 10 seconds. For which we have already given one things. For other than zero order reaction, first order reaction, there is a relationship between we have initial constant. They are going on changing. If it is going on changing, what is the relationship between them? That is simple relationship is T half at concentration 1 by T half at the concentration 2 is equal to the concentration of A2 by the concentration in the first power n minus 1. This is an equation applicable to all order of the reactor. You can apply that equation. Otherwise, you can approach in another manner also. First, you will approach by the methodology method. In the first reaction, it's a second reaction. In the first, it is given 4 to 2 is given by another 2 seconds on. Therefore, 2 by, in the method, how many seconds? X equals to, what is that? The initial concentration in the second test, it is 8 divided by, what is the initial concentration in the first data? 4 power n minus 1. Here it is a zero order. Therefore, 0 minus 1 or the value is equal to 4 by 8, 2 by x. Therefore, x is equal to 4. X is equal to 4. And it should not, and x is equal to 4 means you do not multiply. This is the time taken for this one. Therefore, it is 4. No, what is 4 second correct answer, but it's a wrong answer. Here, x is equal to 4 for here, T half for a process and the initial concentration is 4. But the initial concentration, 8 வந்து 2 மாறி இருக்கு. It is not converted into 4. It is converted into 2. It is further undergoing decreases. Therefore, you should Give this is a 4 for this process. This is a 4 second. This it is a 2 second. This is the final one. Therefore, which is the correct answer, 6 seconds. Now I am extending the problem in this way. Tell me what is the total time taken? What is the total time taken? இப்படி கொடுத்துறேன். நடுவில் ஒன்றை மட்டும் கொடுத்துறேன். What is the total time taken? It is also simple. 4 to 2 மாறுறதுக்கு 2 seconds இருந்தால் 2 to 1 மாறுவதற்கு to convert 2 concentration to 1 concentration, the concentration is 2 times a decrease. Therefore, T half is also 2 times decrease. It is 1 second. Here, concentration is 4 times increase, for 2 times increase. Therefore, the time is also 4 increase. Therefore, the total time is 4 plus 2 plus 1. Similarly, you can extend to any more thing. 1, 2, 3, 4, 5. 8 na எவ்வளவு கொடுக்க வேண்டியது? 16 கொடுக்க வேண்டியது. 16, here 8. For 2 times increase, therefore 2 times increase, and the T of is also 2 times increase. 8 seconds, 4 seconds, 2 seconds, 1 second. Sum up, it will give the whole concentration, one thing. Do you understand this? Okay.
Okay.
So take down the problem. 10% of zeroth order reaction. 10% of the zeroth order reaction completed in 100 minutes. Calculate the time taken for 55% completion of the reaction. For 55% of completion of the reaction. அதுக்கு என்ன ஈக்குவேஷன் யூஸ் பண்ணது? இஸ் ஹோம்ஒர்க். என்ன ஈக்குவேஷன் யூஸ் பண்ணணும்னு சொல்லிட்டோம். K0 is equal to என்ன போட்டிருந்தோம்? x1 by t1 is equal to x2 by t2. இதை மட்டும் போட்டாலே போதும். Conversion by the time taken. Another conversion by the time taken. Substitute பண்ணா immediately you will get the answer. I think almost all type of problem they have given.